Hello, Year 12s. Right, this is the first of a series of videos, and the point about these videos is to try and give an insight into some of the differentiation techniques you're going to need to know in order to do some of the further math stuff in Year 13. Now, it may well be you don't learn these techniques until after we need them, which is obviously not ideal. So I'm just going to go over a few techniques today, and hopefully in the coming weeks I'll just add to the techniques, and hopefully this will help you with your regular maths. Well, it should definitely help you with your regular maths, and also sort of get you ahead of the game a little bit, and it'll be beneficial for you for when you do the further maths. Now, the first lot of functions we're going to look at differentiating are the trig functions. So we're going to look at differentiating sine, cosine, tan, and once you know how to use the derivatives, you can look them up in the tables, and the same thing will apply to all the derivatives of the trig functions. Okay, so you just need to remember a few basics. So the first thing is, let's have a look at sine. So d by dx of sine x. Now, if you differentiate sine, you get cos. Okay, so that would be cos x. If you differentiate cos, so d by dx of cos x, that equals minus sine x. Now, don't worry about why these are what they are. They'll all get explained to you when you get to it in year 13 in your regular maths course. But for now, just accept that this is the case. And the derivative of tan, so d by dx of tan x, is equal to sec squared x. Now, if you don't yet know what sec x is, sec is actually a function which is 1 over cos. Okay, so for example, if cos x is equal to a half, then sec x would equal 1 divided by a half, which would be 2. Okay, so that's what sec x is. So that's what your reciprocal functions are. So how do we use these? Let's just have a quick look. Okay, so if I said to you y is equal to sine of 3x, now what you need to do here is say, okay, well, dy by dx is going to equal cos 3x, but what you also need to do is multiply by the coefficient of x. Okay, so which in this case is a 3, so it would be multiplied by 3. So that would be 3 cos 3x. Similarly, if I said y is equal to, let's say, cos, say 1/3 x, so the derivative, so dy by dx, will equal minus the sine of 1/3 x multiplied by 1/3. And you can tidy that up by writing out this. Okay, so minus a third sine of 1/3 x. Right, so let's just delete this. Okay, and let's have a look at tan. So if I had d by dx, sorry, if I had y is equal to the tan of, let's say the tan of 5x. Oops. Okay, and let's see if we can do this in one go. The tan of 5x is going to become the sec squared of 5x, but we're going to have to multiply by the 5 as well. So you'll get 5 sec squared 5x. Okay, it's as simple as that. So that's how you differentiate these trig functions. Now, let's just make it a little bit more complicated, and I'll give you a few examples of this. So what we're going to look at is the sine and the cos of a linear function. Okay, so for example, if y is equal to the sine of 7x plus 3. Okay, now in this case, dy by dx will have something to do with the cos of 7x plus 3, because that's what this rule over here says. But all you need to do is remember this really simple fact. If this is a linear function, which this is, all you need to do is multiply by the coefficient of x. Okay, and the main thing to remember is it only works for linear functions. If that was 7x squared, then it's a different thing altogether, and I'll go through that in another video. So what we're going to be looking at is a function of a linear function. Okay, so it's a sine of a linear function, in this case 7x plus 3. So we're going to get the cos of 7x plus 3, but I need to multiply by the coefficient of x, so it would be 7 cos 7x plus 3. And the same thing will happen with these other two functions as well, and indeed any other trig function that you've got in your tables. When you differentiate it, if it's a linear function inside the brackets, then you just multiply by the coefficient of x. Right, so let's move on to something else now. Let's move on to exponential functions. Now, you'll already have seen this, I'm pretty sure, in year 12. If y is equal to e to the x, then dy by dx is also equal to e to the x. Now, the same thing will work as in the last lot of examples. So if this is a linear function, okay, so this over here, if that's a linear function, all you need to do is multiply by the coefficient of x. So for example, if y is equal to e to the 3x, then dy by dx will be e to the 3x multiplied by 3, which you'll tidy up and write as 3e to the 3x. Okay, so as simple as that. If you had something like, let's just get rid of this. If you had something like y is equal to e to the 3 minus 4x, dy by dx, so e to the something just becomes e to the something, okay, so e to the same thing, so 3 minus 4x, but I need to multiply by the coefficient of x, which in this case is minus 4. So I'd write that as minus 4 e to the 3 minus 4x. Okay, so as simple as that. So that's how you deal with exponential functions. And the last type of function we're going to look at in today's session is a linear function to a power. Okay, and what I mean by that is, let's say we had something like y equals 3x plus 4 all to the power 7. Okay, now dy by dx is, oops, that's not a very good x, is it? Let's get rid of that. Dy by dx. Now, if you think of this as u to the power 7, if I was to differentiate that, that would be 7u to the power 6. So in our case, the u is 3x plus 4. So that would be 7 lots of 3x plus 4 to the power 6. And can you guess what you'd have to do here? Right? Well, and if you have guessed, and you might have guessed that you have to multiply by 3, and that's exactly what you need to do. Okay, this is a linear function. All you need to do is multiply by the coefficient of x. So you have to multiply by 3. So what you get is 21, 3x plus 4 to the power 6. Okay, so that's all you need to do. Let's just get rid of this. And by the way, if I'm going too quick, just pause the video at any point you like and just make some notes. Let's just do one more. If y is equal to 1 over the square root of 3 minus 7x, okay, the first thing I'd do with this is just rewrite it. So I'd rewrite it as 3 minus 7x to the power minus a half, okay, and dy by dx would equal, so look, you multiply by the power, so minus a half, 3 minus 7x, and then take 1 off the power, so take 1 off that, so minus 3 over 2, and then multiply by the coefficient of x. So in this case is minus 7. Right, okay, so that would be 7 over 2, 3 minus 7x to the power minus 3 over 2. Okay, so there you go. That's basic differentiation techniques. Well, they're not basic, but they're basic compared to what we're going to be needing pretty soon. But that's like an introductory to some of the differentiation techniques you're going to need. And in the next session, what we'll look to do is how you deal with these if it wasn't a linear function. Okay, so this only works for linear functions. In the next video, we'll look at non-linear functions and see how we deal with them. Okay, well, see you next time.